Hey guys, my name is Daniel Woods, and today I'm going to be talking about aquaculture and human health. The planet we all live on may be named Earth, but that tends to be misleading. Over two-thirds of the Earth's surface is covered by water, and as you can imagine, that water has a pretty big impact on us as humans. In fact, Earth's oceans and the life supported within them are intimately connected with human health. Now let me explain. According to research, around 40% of the world's population lives within 100 kilometers of a coastline. This is a significant proportion, especially when considering the ratio of coast to total land area. Now, why am I giving you these figures? Well, humans have to eat, and what we eat usually depends on where we are. It therefore makes sense that seafood is a fundamental part of nutrition all around the world. Peru alone produced over 6 million tons of anchovies in 2018, leading global charts. Now, I don't know how much of that eventually gets onto pizza, and I don't really want to. My point is, whether we're eating caviar or tilapia, we rely on the ocean. And up until the 1980s, we were able to pull more and more fish out of that ocean, increasing yields as fishing techniques evolved. However, this growth has since hit a plateau, and overfishing is taking a toll on the fish populations we so heavily rely on. This has been especially evident in developing countries where fishing actually supports local economies. Enter the practice of aquaculture, or raising aquatic plants and animals for consumption in a controlled environment using anything from ponds to indoor tank systems. Although it has occurred for thousands of years throughout human history, aquaculture has never been more important as a means of seafood production as now, as our fisheries become depleted. This problem is only made worse as we see our population growth show no signs of slowing down. With more mouths to feed than fishing can handle, aquaculture has stepped up to the plate to provide. Only, this new place in the spotlight has served to highlight many of the industry's flaws. If these aren't addressed, we may be no closer to reaching a solution that works. The issues with aquaculture affect not only the fish themselves, but humans as well. Take for example the salmon farms of Norway. Although efficient, the farms are usually crowded, and the fish there suffer from increased vulnerability to disease. Not only that, but the concentrated waste they produce adversely impacts the native ecosystem around them. This problem is not just limited to salmon, or even to fish. The clearing of valuable mangrove forests in Southeast Asia to make way for shrimp farms has harmful potential consequences. Mangroves create habitats for several species of commercially valuable fish, and they benefit humans by absorbing wave energy from incoming storms, preventing erosion and flooding. Another issue to be addressed is the concept of aquaculture as an open loop. This describes the requirement of external input from other sources into aquaculture systems. For example, fish feed for farmed predatory fish is derived from small fish, like those anchovies I mentioned. To be sustainable, this open loop must be closed. And as you can see, without smart implementation, aquaculture can actually cause more harm than good by affecting our environment and eventually ourselves. However, I don't want to paint a negative picture of our main hope for feeding future generations. So let's discuss some avenues by which the problems facing aquaculture are actually being solved. Firstly, there have been great advances in the techniques of aquaculture, allowing for more efficient use of space and resources. A great example of this is in the development of recirculating aquaculture systems. These utilize modern technology to greatly reduce the water and space usage of aquaculture, resulting in compact systems that can be operated almost anywhere. One downside to these recirculating systems is their high initial investment costs, preventing their use in many developing countries. However, there have been great successes in places like the Marshallberg Farm in North Carolina, which produces real caviar that I've actually gotten to taste. And before you ask, nope, I didn't have to pay for it because it was on a field trip. Something to note about the aquaculture I've talked about so far is that it has all been one species. This is important because a major step in the development of the industry, and one that could be its future, is integrated multi-trophic aquaculture, or IMTA. This involves raising multiple species within the same spatial system, and it has many benefits. One of these benefits is helping to close the loop of aquaculture that we just talked about. Many IMTA systems involve the waste products of one organism helping to feed the other, reducing the required input from other sources. This has been researched in Africa, where waste from terrestrial farm animals served as food for tilapia in adjacent ponds. IMTA is also helpful in reducing environmental impacts. Traditional aquaculture's excesses of waste can have devastating effects, including plankton blooms that those here in Florida should be really familiar with. IMTA systems involving fish and associated seaweed species can actually reduce this waste production by a massive percentage. Another great combination for IMTA is that of a fish and a bivalve species like mussels or oysters. These hardworking mollusks eat by filtering particles out of seawater, and they can be useful both separately and in conjunction with another farm species. Systems involving bivalves and fish produce twice the amount of tasty seafood, using the same area. Now, perhaps the most advanced use of IMTA is in recirculating systems, where microscopic algae have been incorporated into biological filters for wastewater, keeping water clean while providing another product that can be used in a variety of ways, including feed for other farm species, again helping to close that loop. And the list of benefits really goes on and on. And speaking of algae, a blooming industry is that of biofuel, in which those very same microscopic algae are harvested for their oil content in a similar fashion to corn ethanol that we use now. Although still in preliminary research stages, the potential of algae farms to provide a decent source of ethanol and reduce corn's land usage is pretty great. As I've just talked about, although IMTA is making aquaculture more viable every day, there are obviously other factors involved in the growth of industry that I haven't discussed. Chief among these is the social pushback that has been observed in several regions, including the US and Canada, due to the drawbacks that do exist. As with anything, time will tell. And to wrap this all up, aquaculture is one of the only industries in the world that must grow with time. Fisheries are already overexploited and our population is still growing. Regardless of the scenario, aquaculture will be crucial to securing a future in which seafood is readily and sustainably available. Thank you guys so much for your time.